2007 edition of NFPA 780 brought about several key changes to lightning protection system standards. These modifications impact design, installation, inspection, and maintenance of such systems. Firstly, the 2007 edition introduced new definitions for several terms. These include clarification of what constitutes a lightning protection system, a lightning rod, and an air terminal. These standardized definitions are crucial for consistent understanding and application of the code. Secondly, the scope of NFPA 780 was revised. This revision extended the standard's purview to include the protection of structures and other properties specifically from lightning-induced fires and other hazards. This expanded scope reflects a broader understanding of the potential damage caused by lightning strikes beyond direct structural damage. Thirdly, the design criteria for lightning protection systems underwent updates. These updates reflect the latest research and advancements in lightning protection technology. The updated criteria ensures that systems are designed to effectively mitigate the risks associated with lightning strikes. Fourthly, new requirements for grounding lightning protection systems were introduced in the 2007 edition. Effective grounding is paramount for safely dissipating lightning energy and preventing damage. These new requirements address best practices for achieving adequate grounding. Fifthly, the inspection and maintenance requirements for lightning protection systems were updated. Regular inspection and maintenance are essential to ensure that systems remain in proper working order. The updated requirements provide guidance on how to properly maintain and inspect these systems to ensure their continued effectiveness. Understanding these changes is important for architects and engineers involved in building design. It is also important for facility managers and property owners responsible for maintaining building safety. Furthermore, fire marshals and other code officials need to be aware of these updates to ensure compliance with current safety standards. The benefits of understanding these changes are numerous. Knowledge of the updated code allows for the design and installation of more effective lightning protection systems. It ensures compliance with current safety regulations. It helps to minimize the risk of lightning-related damage to structures and property. Understanding and implementing these changes is crucial for protecting lives and property from the hazards of lightning strikes. These changes collectively contribute to a more robust and comprehensive approach to lightning protection. They represent an evolution in understanding and mitigating the risks associated with lightning. Anyone involved in the design, installation, inspection, or maintenance of lightning protection systems should familiarize themselves with the specifics of these revisions. The aim of NFPA 780 is to provide guidelines for minimizing the risk of fire, damage, or injury due to lightning strikes. NFPA 780 is not intended to provide complete protection against lightning in all situations. The effectiveness of a lightning protection system depends on several factors, including the design of the system, the quality of the installation, and the maintenance of the system. Therefore, it is important to consult with a qualified lightning protection contractor to ensure that a system is properly designed, installed, and maintained. Now, to elaborate further on each of these key changes, let's delve into the specifics and practical implications. The new definitions introduced in the 2007 edition were designed to eliminate ambiguity and ensure a common understanding of key terms within the context of lightning protection. For example, the definition of lightning protection system clarifies that it encompasses all components required to protect a structure from lightning, including air terminals, conductors, and grounding electrodes. The definition of lightning rod specifies that it is a component of the air termination network designed to intercept lightning strikes. The definition of air terminal broadens the scope to include any device used to intercept lightning strikes, not just traditional lightning rods. These standardized definitions are crucial for clear communication and consistent application of the code requirements. The revised scope of NFPA 780 reflects an increased awareness of the indirect hazards associated with lightning strikes. While direct strikes can cause significant structural damage, lightning can also induce electrical surges that can ignite fires or damage sensitive electronic equipment. By expanding the scope to include protection against these indirect hazards, NFPA 780 aims to provide a more comprehensive level of protection. This expansion includes addressing lightning-induced surges on power, communication, and data lines entering a structure. It also includes considerations for protecting sensitive electronic equipment from damage caused by these surges. The updated design criteria for lightning protection systems reflect advancements in our understanding of lightning physics and the effectiveness of various protection measures. These updates may include revisions to the required spacing of air terminals, the size and routing of conductors, and the specifications for grounding electrodes. The updated criteria often incorporate the results of research on lightning strike characteristics and the performance of different lightning protection system designs. They may also reflect changes in building construction practices and the increasing use of sensitive electronic equipment. The new requirements for grounding lightning protection systems are based on the principle that an effective grounding system is essential for safely dissipating lightning energy into the earth. These requirements may specify the type and size of grounding electrodes, the depth at which they must be buried, and the methods for connecting them to the lightning protection system. The grounding system must have low impedance to allow lightning current to flow to ground quickly. The updated requirements may also address the bonding of different grounding systems within a structure to minimize the risk of ground loops and electrical surges. The updated inspection and maintenance requirements for lightning protection systems recognize that these systems are not maintenance-free. Over time, components can corrode, connections can loosen, and grounding electrodes can degrade. Regular inspection and maintenance are essential to identify and correct these problems before they compromise the effectiveness of the system. The updated requirements may specify the frequency of inspections, the procedures for inspecting different components, and the criteria for determining when repairs or replacements are necessary. They may also address the importance of maintaining accurate records of inspections and maintenance activities. In practical terms, these changes to NFPA 780 translate into several key considerations for those involved in designing, installing, and maintaining lightning protection systems. Architects and engineers must incorporate the updated design criteria into their building plans, ensuring that lightning protection systems are properly integrated into the overall building design. Contractors must be trained on the new installation requirements, including the proper techniques for grounding and bonding lightning protection systems. Facility managers and property owners must implement regular inspection or maintenance programs to ensure that their lightning protection systems remain in good working order. Fire marshals and other code officials must be familiar with the updated code requirements to ensure that lightning protection systems are installed and maintained in accordance with the latest safety standards. The goal of these changes is to reduce the risk of lightning-related damage and injuries. By understanding and implementing the updated requirements of NFPA 780, individuals and organizations can take proactive steps to protect themselves and their property from the hazards of lightning strikes. NFPA 780 also provides guidance on selecting appropriate surge protective devices, also known as SPD, to protect sensitive electronic equipment from lightning-induced surges. SPD are designed to limit the voltage on electrical circuits to a safe level, preventing damage to connected equipment. The selection of SPD depends on several factors, including the voltage and current capacity of the electrical circuit, the sensitivity of the equipment being protected, and the level of lightning exposure. NFPA 780 recommends installing SPD at the service entrance of a building and at branch circuits feeding sensitive equipment. In addition to these technical changes, the 2007 edition of NFPA 780 also emphasizes the importance of public education and awareness regarding lightning safety. The standard encourages individuals and organizations to promote lightning safety messages to the public, particularly during peak lightning season. These messages should emphasize the importance of seeking shelter indoors during thunderstorms, avoiding contact with water and metal objects, and knowing how to perform cardiopulmonary resuscitation, also known as CPR, on someone who has been struck by lightning. By raising public awareness about lightning safety, it is possible to reduce the number of lightning-related injuries and fatalities. The design of a lightning protection system is a complex process that requires careful consideration of several factors, including the size and shape of the structure, the materials used in its construction, the location of the structure, and the level of lightning activity in the area. A qualified lightning protection contractor can assess these factors and design a system that meets the specific needs of the structure. The installation of a lightning protection system should be performed by trained and experienced personnel. Proper installation is essential to ensure that the system functions effectively and safely. The installation process typically involves attaching air terminals to the roof of the structure, running conductors down the sides of the structure, and connecting the conductors to grounding electrodes buried in the earth. The connections between the different components of the system must be secure and corrosion resistant. Regular inspection and maintenance are essential to ensure that a lightning protection system continues to function effectively over time. Inspections should be performed at least annually and after any significant lightning events. Maintenance activities may include tightening connections, replacing corroded components, and testing the grounding system. Proper maintenance can extend the life of a lightning protection system and ensure that it provides continuous protection against lightning strikes. NFPA 780 also addresses the protection of structures containing flammable liquids or gases. These structures pose a particularly high risk of fire or explosion in the event of a lightning strike. The standard provides specific requirements for grounding and bonding these structures to minimize the risk of ignition. These requirements may include the use of specialized grounding electrodes and bonding techniques to ensure that lightning current is safely dissipated into the earth. The standard also addresses the protection of trees from lightning strikes. Trees can be struck by lightning, causing significant damage or even death. NFPA 780 provides guidance on installing lightning protection systems on trees to minimize the risk of damage. These systems typically consist of air terminals attached to the upper branches of the tree, conductors running down the trunk of the tree, and grounding electrodes buried in the earth. The installation of lightning protection systems on trees can help to preserve valuable trees and protect them from the hazards of lightning strikes. In addition to the technical requirements for lightning protection systems, NFPA 780 also includes information on the benefits of lightning protection. Lightning protection systems can protect structures and their occupants from the hazards of lightning strikes, including fire, structural damage, and electrical shock. These systems can also reduce the risk of damage to sensitive electronic equipment. By investing in lightning protection, individuals and organizations can protect their property and ensure the safety of their occupants. In conclusion, the 2007 edition of NFPA 780 brought about significant changes to lightning protection system standards, impacting design, installation, inspection, and maintenance. These changes reflect a broader understanding of lightning hazards and advancements in protection technology. The new definitions, revised scope, updated design criteria, new grounding requirements, and updated inspection and maintenance requirements all contribute to a more robust and comprehensive approach to lightning protection. Understanding and implementing these changes is crucial for architects, engineers, facility managers, property owners, and code officials to ensure the safety of structures and their occupants. The information provided here serves as a general overview of the key changes to NFPA 780 in the 2007 edition. For detailed information and specific requirements, it is essential to consult the official NFPA 780 document and seek guidance from qualified lightning protection professionals.